Okay, for this equation we're gonna use the chain rule in order to differentiate it, and as we can tell it's quite complex. There's 3x inside of sine, sine inside of cosine, cosine inside of cotangent. So there's several things in one inside the other. The chain rule helps us with this. So for the first step, we're gonna take a derivative of the outside, which is, for us is cotangent, and leave everything else in the parentheses unchanged. So that would be negative cosecant on the square times everything we see inside, or not times, cosecant of everything else we have in the parentheses, which is cosine of sine of 3x. There you go, that one's closed, and now we can close this one too. Okay, that was the first step. Now the formula says take a derivative of what was inside, and in order to take a derivative of what's inside we need to use the chain rule again. So taking a derivative of the cosine and leaving the inside, the sine, unchanged. So this would be times, let me continue here so it will not gonna be confusing of what's what, because I'm gonna run out of space here. It's gonna be quite long. Times derivative of cosine will be negative sine, and as we said, the inside will stay the same, which is this sine of 3x. We'll just write that down, sine of 3x, and close it. And we also close this one. Times, like the formula said, now we take a derivative of the inside, which is sine 3x, but in order to do that we need the chain rule again. So we take a derivative of the outside of what we see here, and the outside of it is the sine outside of the 3x. So again, the sine, derivative of sine, and we continue down here, times, that would be cosine, the inside we leave the same, which is 3x. We can close it, and again back to the last step where we take the derivative of the inside, which is 3x, and finally we get to the point where we don't need to use the chain rule anymore. So the derivative of 3x is just 3. So times 3. There you go. This would be it. You can rewrite it, and these two negatives will cancel each other out, so you will have a positive term, and quite long one. There you go.